Well, good morning, everybody. My name is Micah Silverman, and I hope you are having a lovely day. And today, let's see if I can do this. Here we go. We're going to be talking a little bit about your attack surface just got bigger, security warning. So this is a session we lovingly call Stranger Danger, and we're going to be working through some of the application security issues that you may face as a developer. And we're also going to talk, this is kind of a special edition because we've just launched this month-long event called The Big Fix, and we're going to talk a little bit about that. So this is Stranger Danger Big Fix Edition. So it's very early for me. I hope it's not so early for you, but either way, thank you for joining the stream, and let's jump right into it. Quick little bit about me. I am my main squeeze, I would say, is Java. It has been since it was released in 1995. This is where I usually like to say, get off my lawn. But I got to co-author a book on Java. I'm an open source contributor. I'm a DevSecCon chapter leader. If you don't know what DevSecCon is, it's a worldwide organization that brings together developers and operations and security professionals in a meetup kind of setting. We're doing more in-person meetups, but they're always hybrid, so you can drop in, and there are chapters all over the world. I'm a tinkerer. I like to build these full-size arcade cabinets. I haven't built one in a little while. I'm overdue for that. And most importantly, I am a chaotic neutral. Now, if you're not familiar with Dungeons and Dragons, that just means that I like to mess around with people and systems and kind of cause chaos, but not in an evil way. I just like to play practical jokes, and when we're doing a D&D campaign, I tend to, for no apparent reason, trip one of my party members, and then we all have to roll die and see if I'm successful at that, and people get kind of exasperated. Why that's relevant here is it turns out that that kind of alignment is useful in the world of hacking and probing around the edges of websites and systems to see where there might be vulnerabilities. But as a chaotic neutral, I don't actually try to bring down websites and do evil things with my powers. I just like to see what I can do, and then I do the appropriate sort of disclosures. If we want to look at the problem space where we're starting, so if you've been around for a long time like me as a developer, or even if you're new, historically, software delivery has sped up quite a lot. I used to work for big banks and insurance companies. As a consultant, I would help their teams learn Java, and they would often have a month-long or a quarter-long release cycle. So we'd work and work and work for 90 full days before we got to release anything. And right at the end, maybe at the last week, we'd go and kick our work over to a security team for a security audit. And if something came back to us, this was kind of the scary time that last week. If something got kicked back to us, we had to scramble and deal with it very quickly. Well, the good news for us as developers, the software has really sped up. We work in these kind of tight month-long sprints, and we have nice small bits of work to kind of sink our teeth into. And that's really been largely a good thing in our industry. But still, there's been very little thought to security as a developer. We still have to throw our code over the wall a lot of the times and have a security audit right at the last minute before we go and deploy. So there's a lack of security focus throughout the life cycle, and we're not blaming developers here. We have a lot to do as developers, and our focus, the pressure we feel is often on features. We got to release features, we got to get them out the door, and if there is any thought to security, it's more of a anxiety, like I hope this is secure kind of thing, or I hope it doesn't get kicked back to me, because security expertise is often siloed. There's a separate security team that's often by design. And I want to be really clear. We're not saying that security teams should go away. What we're saying is that we can, as developers, we can bring a culture of security and a process around it and tools that will help us be security aware, write code security that's security aware up front, and and catch these things a lot earlier. So when we do throw it over, or when it does go to this to our security team, there'll be a lot less concern that things are going to come back, because we'll have caught security issues before maybe they even ever got checked into our code repositories. And of course, the biggest problem is that customer data could be compromised. And unfortunately, we have no shortage of examples, and we even have recent examples. This keeps happening, unfortunately. So we want to make sure that that doesn't happen, and we can do that as developers. And the big punchline here is that we can become security aware. We can become security practitioners without becoming security professionals, by combining this kind of virtuous triangle of culture, process, and tools. And that's some of what we're going to be talking about today. So we want to look at the domain, the space of the problems that we're talking about. We want to look at modern applications, and we have this new risk profile. Now, this thing that kind of looks like a mountain, it's going to take shape as we go here, but I'll give you a little spoiler. It's the tip of the iceberg. It's an iceberg. And it turns out that how we think of our code, especially in relation to security, maps onto what we know about icebergs that we all learned in grade school pretty well. So the tip of the iceberg, that's the custom code that we write. So 10 to 20% of the code in an application, in a modern application, is custom code. That's the code that you hand write. Now, if you're like me, that left me scratching my head a little bit. Like, that kind of bummed me out a little bit. Like, really, I'm only writing 10% of my application, but that's actually really a good thing. We all benefit in most modern applications from open source. And so we don't have to reinvent the wheel. If I want to use a markdown library, I don't have to start from scratch, because you probably know, if you've ever written anything from scratch, there's a whole process that you go through of finding bugs, driving bugs out. Well, if I'm using a mature markdown library, I don't have to reinvent that wheel. But building an app from scratch, there is going to be custom code. It's going to be about 10 to 20% of what you write. Now, here's an example right out of the gate. This is a very simple Java controller. You might find it in a servlet app or in a Spring Boot app. That's what I tend to work in. And right out of the gate, there's a problem with this code that you might miss if you're not careful. We want to be able to develop fast. We don't want to have anxiety and fear over security, but we want to be able to get rapid feedback to tell us that there are security issues. So let's see. Let me take a look over here at chat. There we go. Cool. So feel free to drop in chat if you see the issue with this code. There's an issue. It's pretty glaring, actually. It's not always, when we do have security issues in our handwritten code, it's not always this glaring, but what we're seeing here is a classic kind of cross-site scripting injection vulnerability. So I have an input called user, and I'm sending that user unaltered. I'm sending that input unaltered to output to the browser. Well, I expect user to be something like a username, an alias, something like that. But it could just as well be a script tag or some sort of malicious injection. And this is a whole class of vulnerabilities. Unsanitized input can also lead to SQL injections and all kinds of nastiness. Now I'm writing code very fast. What would be nice is, as a developer, I could get early feedback to tell me, hey, you have a classic cross-site scripting vulnerability in your code, go fix it. Now, the next layer down in our iceberg here is open source. And I talked about that a little bit. And somewhere in the neighborhood of 80 to 90% of your code base is open source. And 80% of vulnerabilities are found in indirect dependencies. Now, there's a subtlety in that statement. It's not just that vulnerabilities, 80% of vulnerabilities are found in dependencies. That would be bad enough. It's that 80% of vulnerabilities are found in indirect dependencies. That is the dependencies of dependencies. So going back to my Markdown example, if I'm using a Markdown library, well, that library probably has dependencies of its own. And it's those dependencies, those transitive dependencies, that we find 80% of our vulnerabilities. All right. Now, this will be fun. If you can join me, I'd love for you to jump over to this URL, https snyk-chat-goof.snyk-challenge.io, and we're going to do some live hacking here. So go ahead and put in a username. Doesn't have to be a real name. And on the left here, you'll see there's a main room 1. You can add different rooms. This is just a very kind of sparse chat app. If you go over to main room 1, then you can start chatting. And we want to actively hack on this app and see if we can't beat it up. Now, I'm going to talk a little more about the app, but first about what's going on behind the scenes. But first, let's just take a look at the app. It's just a chat app. I can say hello, for instance, and you can see down here it's me chatting. Well, one kind of nice thing about this chat app is it supports Markdown. I talked a little bit about Markdown, and if you're not familiar with Markdown, it's kind of a very compact markup language that allows you to format text very quickly for the browser. So what I just did was I dropped in a heading. So the pound gives you a heading, and it makes it nice and big. And this is great, right, for a chat app. You might imagine that I wrote this app and it was all working, some basic chat. And then I said, it'd be nice if I could have a more rich sort of text. So now I added this feature by bringing in a Markdown library. We're going to look at that in just a second. But one of the things you can do with Markdown is you can drop in links. Now that's handy in chat. We want to be able to drop in links. And the format of a link is a set of square brackets followed by a URL inside a set of parentheses. So that's a really nice way to format a link. And let me make this a little bigger. So now I'm going to right click and open this link in a new tab. And you can see it's just a vanilla link. Now I right clicked and opened it in a new tab because Markdown doesn't have official support for automatically opening up in a new tab. But now I can drop in links. All right, so with all that background, if you're a chaotic neutral like me and you come across a web-based chat interface, I like to mess around with these sorts of things. Again, not doing any real harm. But the very first thing I'm going to try is just to drop in a tag. That would be kind of a quick and dirty way to do an exploit if this were to work, right? So I'm going to drop in this alert, or I'm going to attempt to, and if you notice, if we look down here, it took what I put in as chat, and it spit it back out as plain text. That is, it didn't interpret this as an actual script tag, which is a good thing. That means that there's some level of sanitization happening on the input, because if it didn't sanitize my input, then this would become a script tag, and all of a sudden everybody connected would see an alert. Now, just to take a step back here for a second, this app is kind of a modern stack app. It's a JavaScript front end using Vue.js. It's a Spring Boot backend, and the front end and the back end communicate using WebSockets so that anybody connected can see what everybody else is typing. So pretty modern app. It's using modern tools and technologies. All right, so first attempt at messing around with this site wasn't successful, but now that I know that it supports Markdown, maybe there's another way. Maybe I can take advantage of the ability to put in a script tag or a link. Maybe I can take advantage of a link here and kind of sneak in a cross-site scripting attack that way. So here we have the format for a link, and inside the parens, instead of a URL, I've put JavaScript :alert1. So this is just kind of another sneaky way that I'm trying to get past the sanitizer. Well, this is interesting to me because all that came through now was a close paren. What that tells me is that I've made some progress. Maybe I kind of broke the sanitizer in a way, because it didn't just spit out exactly what I typed like it did when I tried to do a script tag. It actually something along the way broke or got transformed in a way that all I ended up with was this closing paren. So I'm going to try something else here, and bear with me 1 second while I put this in. And I'm kind of doing this from memory, so I hope I do it right. Let's just see. All right. So in case you're not familiar with this, what we're looking at here is this ampersand pound 58 semicolon and ampersand pound 41 semicolon. Those are examples of HTML entities. And if you're not familiar with HTML entities, I thought I had, let's just take a look here, HTML. And this way I can double check that I have it right here. So HTML entities are a way to get the browser to render special characters that might be used in HTML tags, or might represent special characters in other languages. And it's an ampersand followed by pound followed by a number to represent the character. And there are some other shorthands like ampersand LT is a less than sign. Now let's see if there's a table. There's my ampersand. 38? Oh, wait, no, I wanted the semicolon. Let's see. This may not be the best example. Well, let's just see if I did it right here in just a sec. Now, this isn't going to work exactly, but what I'm trying to do here is trick the sanitizer into letting this through. Imagine a naive version of the sanitizer is just doing JavaScript : that's what it's looking for. And I'm trying to trick it by not having a colon, but by having the representation for that instead through an HTML entity. And the order of operations is the browser will first convert this into a colon, and then if it gets past the sanitizer, it'll kick into the JavaScript engine, and it'll execute this JavaScript. All right, now this time nothing came through at all. It's like the sanitizer gave up. So that tells me that maybe I've made even some more progress. So I am going to do one more thing here, and this is going to work, and I'll tell you why. It works because of a combination of the browser being too permissive and a vulnerability in the library that I'm using, which we're going to look at in just a second. But let's parse this line now. So if you notice, I still have ampersand pound 58. And that is no longer a valid HTML entity. But your browser and browsers, since the very first browser I used, which was in 1991, which came out of CERN, it was NCSA Mosaic, it was called. That browser from 1991 to 2023, browsers have always been too permissive. If you're writing Java code and you forget a semicolon, the compiler complains to you and you have to fix it. Well, the browser will happily interpret this as a colon. So we have JavaScript colon followed by a keyword in JavaScript document. And I promise we'll get to Java very quickly. So document is a keyword in JavaScript, in particular in the browser, and it ends up just being a no-op. It's just a reference to the document in the DOM space, and then we have a semicolon, which is the statement separator in JavaScript. Then we have an alert one, and this ampersand pound 41 is a closed paren, just in case the sanitizer is looking for matched parens or something. I'm taking extra effort to get past the sanitizer. All right, so let's see what happens there. And now if you notice, we have a link, and if you click the link, you get an alert. And not only does this happen for me, this happens for you too. It's one of the reasons that I like using this chat example because of the nature of WebSockets. I've now, this is in a way a distributed cross-site scripting attack because now this affects everybody. And you might say, well, it's just an alert, no big deal. And I would agree with you, but this opens the door to, this is like a foot in the door. And this is what attackers do. They get a foot in the door, and now maybe I can craft a more creative JavaScript payload that will exfiltrate your cookies or will show me your local storage or something like that. So being a chaotic neutral, now that I've gotten this far, I would go through the proper channels to disclose and say, hey, you have an issue on your site here. I can do a distributed cross-site scripting attack and maybe get information that I shouldn't from a bunch of people. All right, so let's take a look at the code now and how we might be able to address this as developers. So what I want to show you here is if we look over on the left, I forgot to set up my Zoom tool. So hopefully you can see this okay. But what we're looking at here is a modern application. What I mean by that is this is a Java application. It's running in IntelliJ. It's got a Vue.js front end, a Spring Boot back end, and it's all contained within this one project. This is a multi-module project. Now, here, this is my package JSON. If you're not familiar with it from the world of Java, these are my dependencies. This is similar to what you would find in a POM XML, and we're going to look at the Java side of the world in just a moment. But you can see here I was trying to be a responsible developer. I brought in this library called marked. And then all I had to do, this is great, in 3 lines of code, I was able to add markdown functionality to this application. I import it. I set a bunch of options. You can see here that I'm turning on the sanitizer. And then whenever I render a message, I pass that message into the marked function. So it's going to take that message. It's going to look for any markdown. It's going to convert it to HTML, and it's going to render it on the page. And it's going to do it in a way that should be safe because the sanitizer is on. But we just saw that there's a problem with this code. So how can I still move fast as a developer, but catch things like this? Here I am trying to be a responsible developer and not reinvent the wheel, but you and I now know that there's an issue. Well, I want to show you the first Snyk tool here, and this is IDE integration. So right in IntelliJ or Visual Studio Code or Visual Studio, whatever IDE you use, you can install this Snyk IDE integration. And now I can run this analysis on my code, and it's going to look at 4 dimensions. It's going to look at my custom code, my open source dependencies, and then it's going to look at my container configurations and my IAC configurations, my infrastructure as code configurations, if I have any. Now, this application is purposely vulnerable, so there's a lot of vulnerabilities that have been found. But let's take a look. I want to draw your attention. First of all, notice that it's analyzed both the Java and the JavaScript side of the world. So Java is my POM XML, and then JavaScript is my package JSON, and it's analyzed all of those at once right within the browser. So this allows me to really dig into my modern application and make sure that all aspects of it are getting checked. Now, where we're going to focus on for a moment is the JavaScript side of the world, and you can see that there's a boatload of issues, but in particular, there's all these issues with marked. And if I click on these individual issues that it's come up with, I can look at some of the specific feedback that it's giving me on what these issues are. But more importantly, I can see I get these red squiggly lines, kind of like we're used to seeing for syntax errors or compiler errors. And it's telling me that there's an issue with this dependency. And then I get more detail. And this is kind of the aggregate of all the issues that it found with Mark. And the punchline here is it's telling me to upgrade to this version of Marked. And then all of these problems go away. And it's giving me a lot of detail about what the issues are and how to fix them. So it's not just that it shows us what the issues are, it's that it gives us specific remediation advice. And that's super useful. Now, so this is our open source dependencies. Let's take a look at some code, some custom code. And here it's telling me that I have an issue in my custom code, and this hopefully will look a little familiar. This is exactly the issue that I showed before, and it's alerting me to the fact that I have a cross-site scripting attack vulnerability, and it's giving me the red squiggly lines to show me exactly where the issue is, because I'm taking an input and I'm sending it to an output unsanitized. Now, the cool thing here is if you look at the bottom, it's giving me examples from real live open source projects. And it may be a little hard to see the contrast here. It's giving me a diff with a red line for what was removed and green lines for what was added. But it's showing me 3 specific examples of projects that had this same vulnerability and how they went about fixing that vulnerability. So that is super handy and super useful. That will allow me to fix these issues before they ever hit my CI/CD, before they ever hit my shared source code repository. I can take care of them right away, and they kind of never see the light of day. I don't have to wait for them to get kicked back to me by my security team. All right, now I want to deviate from my usual script a little bit to talk a little bit about this big fix event that we have going on right now. And I need to get to the right place to do that. Okay, big fix. So, and why I'm bringing this up is what we've done is we've gamified the these kind of fixes, and you can get points and prizes by fixing applications as you go here. So now let me just make sure. I think I already did this, but let me just make sure that I've synced this up. Okay, so let's go take a look at the big fix. And if you go to the front door of the Snyk site, you'll get a link directly over to here. I'll drop it in chat. But When you go over here, we have a very simple way to register. We just need your name and email. And let me just make sure I'm going to use the right one here. Yeah, I'm just going to use an email that'll get an email over here. And then you submit. Now, what's going to happen after you submit is you're going to get a magic link that gives you access to the event here. So let me stop sharing my screen for a second, and I'm going to jump over to my email and grab that magic link. Bear with me a second here. There we go. Okay. Let me add my screen back in again. Awesome. All right. So you're going to get a magic link in email. You can just click the link directly. I copied it just so that I could show you here. And then you get to the big fix, and you're going to get assigned an alias. Couple things I want to point out here are we have this kind of stepper information as you go that helps you kind of that leads you through how to participate in the big fix, and you can take a tour of the app. So this will show you the various parts of the app and what it all means. And we have this leaderboard that shows how people are doing, how many fixes that they've made. All right, well, the next thing I need to do now that I have this alias and I'm in the big fix, so to speak, is I need to connect Snyk to it. So I'm going to click on connect Snyk, and you can, from here, you can log into your existing Snyk account, or you can create a completely new free tier developer Snyk account, fully functional with all the features, and you can do it right from here, either through GitHub or Google, or through a bunch of other different ways, Bitbucket, Azure AD, whatever whatever IDs you have, we can support. Now, I seem to already be logged into Snyk here, so will this one be okay? I'm going to log in with a different user. Bear with me a second. I'm going to log in as a different user. All right, so I'm going to connect Snyk. I'm going to go by Google. I am still logged into Snyk. This is what we call the demo monster. I wonder if I can come in this way. All right, one more time. A little bit of the demo monster, but I want to start with a greenfield account. So now one of the cool things that we can do here is once you've registered, you only have to register once. And then if you come back to the big fix, say on a different machine, or your session's expired or whatever else, you can just put in that same email address and we'll send you a new magic link. All right, bear with me again one more sec. I am going to go and use the same, actually, I'm going to use an entirely different email address just to make sure it's not something I've used before. Oh, I think that's why I was getting that, because I had already used that email address. All right, let's use a different one. Let's call this 1,000. I'm pretty sure I haven't used that one before. All right, and now I'm going to get a new magic link. Let me go and grab that new magic link. Just take a moment here. A little bit of the demo monster, but we'll get past it. I believe in us. Come on, email. You can do it. Might have put in the wrong thing. Oh, I did put in the wrong thing. Right. Like I said, I was using a brand new email that I'd never used, which means that I do have to register. I can't just use that interface. So I'm back at the registration page. There we go. And now I will get a new magic link in theory. Just waiting for email. Huzzah! I got it. All right, here we go. I got a good feeling about this. Okay. All right, so here's my magic link. I got a totally new alias because I'm starting fresh. Now I'm going to connect Snyk. This is what I was trying to do before, and this should be nice and fresh because it's in a incognito window. Of course, now I need to go find my. I need to go find my my password. All right, this is taking a little bit long, but we will get through it. I believe in us. Okay, almost there. There we go. Okay. All right. Now, if you've never seen this before, this is an OAuth flow. You don't have to worry about those details. But I'm linking my Snyk account to this application. 049923 049923. All right. So now this is what we call a consent form. And here is where you have a little drop down. If you have multiple Snyk accounts or you're part of an organization, you can choose which account that you want to use here. So I'm going to choose this account. And if you notice, the only thing that we're doing to connect this to the big fix is we just want read access. So we don't need any write access to your repos or anything like that. It's all read access. And then, awesome. So now that we're in the big fix, I can see that I get a list of the projects that that I have in my Snyk account. And if you're wondering where these projects come from, well, I can go to my Snyk account and I can see which projects I've imported into my Snyk account. So I have this application called ChatGoof. And if I go and look at that, I can see that I have a critical 12 high, 19 medium issues, vulnerabilities with this application. And we saw that a little while ago. And this kind of matches what I'm seeing over here. If I look specifically at this project 112.19.0, 112.19.0. So everything matches up. So this is showing me what's in my Snyk account. And then to add it to the big fix, here's kind of the crucial point. I'm going to add it to the big fix. And I don't have to add all my projects. I'm just going to choose this individual project. And now that it's added to the big fix, I can go and fix these vulnerabilities. And when I do that, I'm going to get points on the leaderboard for making those fixes. And you can see we have a bunch of participation and a bunch of people on the leaderboard already. All right, now this the scoring, the leaderboard updates about every 20 minutes. So I'm not gonna I'm gonna make a fix. I'm gonna push it up, and then maybe by the end of the session, we'll be able to see that I've gotten some points for doing that. But we'll check back in with that. So what I'm gonna do here is I am going to take the advice. Bear with me a sec here. Package.json. I'm going to take the advice of the feedback that I got, and I'm going to change this to a different version of Mark. It's actually the latest version or close to it. And I'm going to install that. Okay, and I can see that my package JSON and my package lock.json have been altered, and I'm going to check that in. Updated, marked, git push dog-eared main. Oops, gotta spell things right. Spelling is fundamental. Okay, so I've pushed up that change. That's going to trigger a rescan of this project, and we'll see these numbers drop because I fixed some of these vulnerabilities. And then maybe by the end of the session here, we'll see that that I get a score on the leaderboard here. All right. We're going to leave the big fix for a moment and jump back over to our presentation here. So with all this under our belt, we focused a lot on open source and on our custom code, and we unfortunately have a bunch of examples of the problems that not paying attention to security leads to. Now this is from a number of years ago now, but it's still a great reference. The Equifax breach in the U.S. In case you're not familiar with it, 140 million U.S. consumers were affected. That's like a third of the entire population of the United States. It took 76 days for it to be discovered. It's cost $2 billion so far. And the thing that unfortunately history repeats itself with this, and why we still use it as kind of a go-to example, is that it was entirely avoidable. The timeline of this is that in Apache Struts, there was a security vulnerability. That security vulnerability was discovered, it was disclosed, it was patched very quickly. That's the good news. That's the good news about open source, is that we have a lot of eyes on things, and when vulnerabilities are discovered, they can be fixed very quickly. The bad news, the other side of that double-edged sword, is that companies that are using these open source libraries sometimes are slow to react. And it's at the point that a vulnerability is discovered and disclosed that attackers go to work, because they know that there's going to be some sort of lag, in this case, something like 76 days before a between the time that a vulnerability is patched and a company actually applies that patch. So this breach was entirely avoidable. It could have been avoided simply by updating a version of Apache Struts to a version that fixed that vulnerability. Similar to what I just showed you with the Markdown library, where all I did was bump a version, and now all those vulnerabilities go away. So the big punchline here is that as developers, we can catch this stuff early and not have it ever see the light of day, or we can update very quickly and not fall into this kind of history repeating itself dynamic, where a vulnerability is patchable but hasn't been patched, and it leads to a breach. So if you're like me, you tend to think of your application as your code. This is my code. This is my application. This is what I've written. But we want you to start thinking bigger, because really the footprint of your application includes all of your open source dependencies, and it can include things like your container configurations, right? That expands the footprint even more. And we're going to see in just a little bit that when we're talking about the world of containers, now we have other considerations beyond our code. Is the operating system running in the container, does that have known vulnerabilities? Do we have a raft of utilities installed in that operating system, that image, that maybe we don't even need? So we have even bigger considerations, and Snyk's tool set can scan your container and your IAC configurations as well, to give you the same kind of feedback that we saw with code there. All right, here's another example. So a Spring serverless example, and this kind of drives home the point about how we want to expand our thinking about the footprint of our applications. So Spring serverless example, we have 222 lines of custom code. That's a nice modest function. It's not huge, it's not tiny, but we're leveraging all of these open source libraries. There are 5 direct dependencies, and some of them you can see here have to do with AWS. Some of them have to do with Spring. Some of them are DynamoDB. So from these 5 direct dependencies, if you do a Maven tree, you'll see that that is a total of 54 dependencies. So including indirect dependencies, we have a total of 54 dependencies. So the big question is, how many lines of code do you think is represented in this 54 dependencies? Now, if you're like me, I thought, all right, this is a trick question. This is going to be a lot of lines of code. 222 lines of code. My first guess at this was 100,000 lines of code. Nice round number. And that's absurd, right? How can we go from 222 lines of code to 100,000 lines of code? Well, it turns out that this is actually nearly 500,000 lines of code when you take these 54 dependencies into account. So we have to start thinking bigger in terms of the footprint, the actual footprint of our application. And that's why we want to scan our open source dependencies and our custom code so that we catch any security vulnerabilities early. Now, you might not be surprised to know that attackers are targeting open source specifically because, like we saw with the Equifax breach, one vulnerability, many victims. The thing to come back to the Equifax breach, the thing about it is that Equifax was probably not a primary target, meaning attackers didn't necessarily, this is a bit of speculation, but it's likely that attackers didn't say, okay, let's go attack Equifax. More likely, they said, okay, there's this known vulnerability. Let's do a scan of the open web and see if we can find applications that have the fingerprint of this vulnerability. So Equifax got caught up in a scan. And then once it was clear that Equifax was using this older unpatched version of Apache Struts, then it became a direct target. But it probably didn't start out that way. Now, another example, a more recent one that you've probably heard of is Log4Shell. And in the Log4Shell vulnerability, this is kind of a happy ending sort of story because this was a very serious remote code execution, kind of highest level, everything's on fire sort of vulnerability that was discovered, and it was patched and updated very quickly. That's the good news, is that as far as we know, there weren't any Equifax style breaches directly related to Log4Shell. But it's a good case study in the kind of impact that these vulnerabilities can have. So 17,000 Java packages were impacted. Lots of Java packages use Log4Shell. And in the first 3 days that this was discovered, there were, in our analysis, there were the better part of 1 million attempted attacks. So these are the kind of probes that attackers are doing to find out if a website that's using Java has this vulnerability. So 800,000 attempted attacks in the first 3 days, and we also find that something like 57% of projects have log4j as a transitive dependency. Again, that word transitive or indirect, that's really important. My first thinking when this happened in December of 2021 was, well, I use Spring Boot. I know Spring Boot uses SLF4j and logback by default, so I probably don't have to worry about this. That was my first thought. But then I remembered, well, I use a lot of open source dependencies, and those dependencies may have log4j in them. Because in Java especially, we love our abstractions, and there's no reason I can't have an application where part of it is using SLF4j and part of it is using log4j, and everything just kind of hangs together. So I couldn't just rest assured that by virtue of the fact that I was using Spring Boot, I didn't have this vulnerability because I might have a dependency that was using log4j. So, like I said, this was found and patched and updated. Everybody was scrambling around and it was updated very quickly. The open source community really rallied. We produced a cheat sheet at the time to help people mitigate this vulnerability while the fix was being discovered. The vulnerability we're going to look at in a little more detail shortly relied on network access, external network access, or outbound calls, I should say. And so one of the early mitigations, while it was still being fixed, was to update your firewall policies to make sure that a certain type of network connection couldn't be made. But in very short order, there was an update and a patch. Now, what presentation wouldn't be complete without a poorly drawn diagram? And here's my poorly drawn diagram of kind of the anatomy of the log4shell vulnerability. And I am going to attempt to, I'm going to attempt to get a zoom on the screen. So this is a little bit of behind the scenes work here, but bear with me a second because it'll be useful if I can zoom in here. Let's see if I can use this. So this is what is it? There we go. There's a little zoomer. Okay. Okay, that's okay. Let's see if I can. Does control allow me to use double tap 3 fingers? Bear with me a sec here. Is this what I want? I think that might be what I want. Yes, that's what I want. Okay. All right. Now I just have to figure out how to make this frame a little bit bigger. Let's see. Double tap 3 fingers and drag to change zoom. Okay. But what I'd like to do is expand this. All right. Not sure how to do that, but we're going to roll with what we got here. Okay. All right. We're going to try to use this as a little zoomer. All right. Bear with me one more second. I'm going to try one more thing to, there we go. Aha. The system works. Huzzah. Okay. Now I can zoom in a little bit, make it a little easier for you to see, hopefully. So how did log4shell work? Well, here's the thing. The enabling technology is Jindy, Java Naming and Directory Interface. And if you're not familiar with this, it's a great Java abstraction, right? We have all these directories that we interact with all the time, usually behind the scenes, like DNS is a directory, domain name service, LDAP, lightweight directory access protocol. Those are all examples of directories, and Jindy gives us kind of a uniform interface to interacting with them. So Jindy used to be a part of the log4j stack, and there's a whole history behind how that happened. Suffice it to say that it was kind of a normal open source process that led to Jindy being included in log4j. That is, a developer said, hey, I have this use case. It would be handy if I could have Jindy in log4j. This developer put up a patch and a justification for the use case. They included tests, and the the maintainers of log4j said, "Hey, this all looks good," and it was merged. Yeah, go right ahead and ask a question. Of course, anybody can ask questions. Just feel free to drop them into chat. I'll wait for your question, and I'm going to continue on here, and I'll keep an eye on it. But I love questions, so keep them coming. So Jindy was added to the log4j stack, and if we look over here at what's going on, if you drop this carefully constructed interpolated string, if you can get that to be logged out, what that does is it triggers this Jindy stack, and now it's going to make an external LDAP call, right? And if you're not familiar with LDAP, you might be familiar with Microsoft Active Directory. That's using LDAP behind the scenes. But when I think of LDAP, I tend to think of things like organizations and people, sometimes devices. Well, it turns out that with LDAP, you can have it's perfectly valid to return a reference to a Java class. This is another external reference. So first we make an LDAP call. The response from that LDAP call is a remote reference to a Java class. And then Jindy happily makes an HTTP request and returns that serialized Java class as a byte array. That byte array comes back, Jindy happily deserializes it, and now by virtue of the interface mechanism in Java, we're executing this evil class. And the important thing to point out is that evil class was never a part of the class path of this application. Evil class implements an interface that Jindy knows how to execute a method on that interface, and now you have mayhem. And this led to remote code execution, shell access. That's why it's called log4shell. Now, usually I have kind of a deep dive example into log4shell. I'll have a bunch of references at the end. You can look at this yourself if you're interested, but the bottom line is, after a number of attempts, Jindy was simply removed from log4j. That was the simplest and safest way to get rid of this vulnerability. The use case, the original use case for Jindy, was not strong enough to keep it in log4j. So as a safety measure, Jindy, the Jindy capability was completely torn out of log4j, and then this vulnerability, log4shell, went away. All right, let me take a look at my question here. All right, so the question is about specific languages from our friend Wally G here. Started learning a new programming language called Rust. High-level languages like Python. And the question is, what's more suitable for cyber and information security, Rust or Golang? Well, Wally, I will answer truthfully and say I don't know either. I don't know any of Rust or Golang, and I can barely get by on Python. My good friend and the leader of our DevRel team, Randall, is a Pythonista. Really loves Python. He's been trying to get me into it for years. I can write just enough Python to be dangerous, but I don't know enough to answer this question about Rust or Golang, I'm afraid. So apologies for that. I haven't used either of those languages. What I will say generally is that all languages, whether my focus is mainly on Java and JavaScript, have issues and vulnerabilities, and ideally you'll have the tool set like Snyk provides to be able to give you that early feedback so that you can write safer, more secure code. But pretty much any language can be used in a secure way. Any language can be misused, and you can write insecure code in any language. That's my experience, at least. So it's not necessarily about the language. Now, different languages are suited better to different applications. I'm not saying that all languages are great for everything. I have a bias toward Java. Don't hold that against me. But I think the best answer I can give, Wally, is that any language can be you can write secure code, and with any language you can write insecure code. And part of the secret sauce there is to have tools that will give you that feedback early. All right, now we're just a couple minutes away from the end here, so I'm going to speed through some slides here. So I hope you'll indulge me. Working our way down the iceberg, the entire picture, or the big picture, we spent a lot of time in code and open source, and I alluded to the fact that we also, further down the iceberg, we have containers. Our container configurations are kind of a new vector of attack, because maybe our code, imagine a scenario where I've driven all of the vulnerabilities out of my code and my open source dependencies, but now I'm deploying my code to an unsafe environment in a maybe I'm using an old container that has a bunch of known vulnerabilities. So we want the ability to scan our containers and then to get the complete picture here of the iceberg. The last layer, if you will, is infrastructure as code. The NSA has identified the #1 cloud vulnerability as misconfiguration in things like infrastructure as code and container configurations. We have these very powerful tools at our disposal now, wherein 10 lines of code, I might be spinning up hundreds of instances of a potentially vulnerable um, virtual machines. And so now that things like network access and storage and servers are deployed as fast as code, we need the tools to be able to scan and identify those vulnerabilities as well. Let me jump to my punchline code here, my punchline slide. So here's the punchline. We want to, as developers, we want to start integrating the ability to scan our code and our open source dependencies and our container configurations and our IRC configurations. We want that to be a part of every step in the software development lifecycle. So it's not just about scanning my code as I'm writing it. We also want to be able to hook into our CI/CD systems, and we want to be able to fail builds just like we do with test suites. If tests fail, we fail the build and we don't deploy it. Well, if security vulnerabilities are discovered, we want to fail the build in the same way and catch those before they ever get out to production. But in production, we want to be actively monitoring our production servers, because Log4Shell is a really good example of a case where on December 9th, 2021, everything seemed right with the world in production. And then on December 10th, everything was on fire because new vulnerabilities get discovered all the time. So you may have heard the term shifting left. We say shifting left is not enough. We want this virtuous feedback loop where we're iteratively bringing security into our practice as developers over time, and continuing to refine and build it into our entire life cycle. All right, one more plug for the big fix here. This is an event that's going, it just kicked off yesterday. It's a month-long event. We're encouraging everybody to find and fix vulnerabilities, and then you have the opportunity to win all kinds of prizes. And on February 28th, if you go and look at our landing page, we have a whole schedule of events. Let me just bring that up really quick. If I go to snyk.io, and right at the bottom here, you'll see that we have a link to the Big Fix event. Then on February 28th, we have a live stream schedule that's going to cover all of the regions throughout the world, and it's going to be a 24-hour live stream, and that's at the end of February, and it's in the middle of this Big Fix event. All right, so with that, I will say thank you for your time and attention. I hope this has been useful. This will be posted on our YouTube channel, and you can always come back and revisit it. Thanks for the question, Wally G. Thanks for being here this morning. My morning for me, maybe afternoon for you. And with that, I will leave you to your day. Thank you very much again, and I will sign off now. All right, y'all. Bye.